everyone. Let's just give some time for others to join. Can you hear me okay? Hey, everybody. So we're just going to give a couple more minutes for people to join. Okay, let's go ahead and get started. Um, does anybody have opens that are not captured in the agenda? Okay, the only topic we have on the agenda is for Mark. Not sure if Mark is going to make it today. Oh, here he is. Hi, Mark. Thanks for joining. I see that on the agenda is your topic for taking comments on the working group workload definitions.
Um, I I don't have anything new to report. If anything has anything, anyone has anything, I'm willing to listen. I think we still have multiple competing definitions. I think it's getting in the way of progress, honestly. And I see this not just in the context of Whimsy or the consortium, but I also see it in the context of my work at the bank. Yeah, and these tend to become a contentious, topics because they have like technological and frankly political implications. People have vested interest tied to a particular definition of a workload is. So, I think at least between the consortium and Whimsy, there has to be some commonality because that will help steer the rest of the industry. But I don't have, I like the definition that Whimsy has provided, but I think there may be equally sound competing opinions.
Is there contention, the definition of a workload or the definition of the scenarios that the workload needs to support? Or both?
Both?
Okay.
Yeah. And so, workload does its, and especially when you try to assign identity to a workload, and you think about like your typical distributed system, where does this identity live? Who maintains it? How is it updated? What goes into establishing it? It's a complicated topic that we should probably break down and discuss various aspects of. Hank has his hand up.
Yeah, just a quick litmus test. Is there a counter example to the definition in Whimsy that would create contention because it's obviously conflicting?
I think some of the difficulty is to translate this workload into what happens practically on the ground, right? So I do not know what other competing definitions exist, certainly not at the top of my head.
Okay.
But let's just take an example of a cloud application. Your cloud application might have a load balancer through which it receives requests. And it may contain, some, compute units, and then they may contain some serverless units, and they may internally to that work communicate via, various queues and notifications, etc. So, and then maybe it goes and reaches out to some sort of backend to obtain some data or store some data. Okay, so there isn't like so if I'm trying to connect to that workload and send it a request, I need to know that on the other hand side of me is a workload I trust, because I don't want to, perhaps submit my sensitive data to a workload I don't. So there's certainly one facet of a workload being presented. Then if some component inside this, aggregate workload that I just described wants to reach out and get information from another store, then, what kind of identity does it present? Is that an identity of the, perhaps the compute unit that's, requesting some data? Then does it represent the totality of the workload around it? What happens if, something about the rest of the workload changes? And, perhaps I'm being a little like pedantic, but these are the kinds of, things that we need to have answers to.
Can I add? Yeah, can I add? This is Mari, just real quick. And the multiple workloads which may be on the machine, right?
Well, they're different, right, from each other. Like I don't think that we have a definite tie-in of a workload to an instance of a device. So let me explain precisely why I say that. So device attributes, for purposes of how I think about it, and feel free to challenge me, are things that are more like claims in the workload identity that may, for instance, pertain to location, right? So if I have a regulatory requirement that processing happens in a particular jurisdiction, and the device's geographic, positioning becomes an important claim in the overall identity of the workload. But then I can have two workloads on the same device that are isolated and distinct from each other that may share that claim by virtue of running on the same device in Germany. Or I may have some claim regarding the compliance of the device. Maybe, the device needs to have passed, I don't know, some sort of anti-malware check, or have its firmware up to date or whatever. That maybe not related to workload identity, because maybe confidential computing doesn't care, because those claims are out of its DCB. That for whatever reason, we still have an obligation to. So that's why I'm saying like device is important, right? And having devices, identity elements in the workload identity as claims is important. But a device is not a workload.
Well, but how can we be sure that on a device with multiple workloads, that the communication is only going to the workload that you select,
The
and there's
way
not
you
possibly a front-end processor or something else in the way.
Yeah, the way you do that is you will, without confidential computing, you can't, generally speaking. With confidential computing, your workload, your enclave, right, for instance, will generate an asymmetric key pair, will perform remote attestation and obtain credentials for this workload. And confidential computing then guarantees that there is a firewall between this workload and other stuff running on that same device. So in that case, you know that you are really speaking to that identity. The problem is that this identity may be talking to other parts of the workload it's representing, which now is disaggregated and lives, on different devices and talks to different things. And our existing mechanisms don't really capture that. And again, maybe that's too much to ask. That could very well be. I just want to ensure that we are capturing the entirety of the problem, even if we solve a part of it.
Okay. Quick side question again. So is part of the problem statement here a identifier composition? So from the ephemeral part, that is somehow the workload, and the hardware part or the virtual machine part that it's running on.
I would feel a lot better knowing that whatever I designate as my workload, right? So, which is a combination of different pieces of software and their configuration that is deployed together to perform a function, right? Which is the Whimsy definition. That they're all attested in concert as a unit. So if a part of that workload is subverted, somebody managed to get into the system and redeploy some sort of serverless bit or whatever to introduce malware, that the workload identity doesn't just continue on its merry way, because that can be a serious vulnerability.
I see.
And the mechanisms for that, are TBD. I'm just saying this is the security concern.
So Mark, why do you have such confidence that, okay, so you may have a host and it's running one of the, TEE, SEV enabled chips, but it's still only got one NIC card and one bus.
Yes.
So my communications to workload A are still going through that single COM channel.
Well, that is the IDE specification from PCI SIG, right? That problem is getting addressed at the level of hardware where you're going to now be able to overlay encryption over the otherwise clear text PCI bus and have multiple workloads communicating securely and isolated from each other, even on that. But sort of a more nuanced answer to your question here would be that we do the best we can with the technology we have, and once PCIe SIG specification for IDE is broadly enough deployed, that becomes a requirement. Until then, it's best effort, and that's, I think, generally what we do.
Okay, so TDISP 6, you said?
So I think there is a specification from like the DX Connect and TDISP. So there is the one, but there is also the IDE specification, integrity and data encryption, from the PCI SIG working group. I don't remember off the top of my head how they relate to each other, if at all.
Okay.
But we need to
want,
have an understanding of like a mapping of all of these bits.
So if you want an explanation, I can give you a quick explanation of how TDISP and IDE and everything come together.
Yes, please. Yeah.
So to handle confidential, so the idea is that you will have TDISP compliant devices, which part of the requirements of a TDISP compliant device is the ability to separate the resources assigned to a particular TD or enclave from each other. So when you announce that you're a TDISC compliant device, you're saying, I speak IDE for my link encryption, I speak SPDM for my measurement, attestation, and authentication. And what happens is, either through SCVIO, TIO, or TDX Connect, you are using this TDISC standard to bind these, what they call TDIs, to a specific enclave. And by part of the TDISC standard is, how do you bind these devices to the enclaves securely? And that's where the use of IDE and SPDM come in. So TDISC is going to be the overall confidential compute device. Essentially, it stands for, I think it stands for like TEE device, something security. Forget the I, security protocol. And the idea is that you're going to have a device that says, I can separate either via, TF or multiple VFs, a TDI given to each individual TD on my system, or enclave, depending on the terminology you want to use. And by doing that, the card itself is guaranteeing the separation. And this is part of a much larger question of, how are we going to orchestrate this information in addition to the host information? And then we need to get that information from everyone we're going to talk to on the other side as well, to make sure we're trusting who we're talking to as well, which is where I think part of this conversation was going. How does the relying party on the other end know that it can trust not just the host is running a TD inside an enclave, but all the PCI devices that are assigned to that enclave are also trustworthy? And that's where TDISC comes in. You'll get a quote from the TD. It'll wrap up everything, including measurements from the TEE processor and any devices that are added to the TEE. And you, as the relying party, will be able to say, okay, I know that this is this NIC by this vendor. These are the measurements I got from it.
Yeah.
I know that I can trust it.
So I see there are a couple of hands raised. Let me just quickly respond, because I'm trying to generalize what you just said. Basically, a workload is a graph of some sort. In that graph, you have different units pairwise communicating with each other, right? Now, it's rarely full mesh, but like for every unit in a workload, you're going to have something else it is talking to, either locally on the machine or cross machine. And I believe the proper way of handling this is basically saying a workload should ensure that all of these pairwise communications are attested, and then its communications with the outside world can likewise be trusted. Now I'll cede the floor. Giri, Mohammed.
Yeah, I'll go. So, I mean, I agree with what was said about TDISC just now. And like for CCA, we actually do have, we actually have a way to convey that as part of the realm attestation. I think the question to you, Mark, is, were you considering a model where you only had local extensions for devices that are directly attached via an interface like PCIe, or were you considering that the workload could take advantage of devices that could be networked and in a remote, as far as the workload processing is concerned?
Well, look, for trust to be sound, whatever is captured by whatever comprises a workload needs to be on the level. Okay, let's just make that a improvised general statement here. And what comprises the workload would be some total of devices, their peripherals, that computation runs on within that workload. And these individual sub-workloads, whatever you want to call them, they are perhaps all deployed as a unit, because that's how we think of a workload. A workload is a collective thing that we trust in its entirety. So I'm in the North Star sense, I would like to capture and convey that kind of information. But again, that's sort of the security purist speaking on me. So, again, I welcome this to be challenged. Mohammed, you've had your hand up for a while.
Yeah, I wanted to talk about the definition of workload a little bit more. So the definition that the Whimsy workgroup has, I don't think there will be any piece of software that will contradict that. I mean, it's so generic. Everything in the world, every software written can be defined under that term. So it's I think too broad, too generic, that is not going to be very helpful for us to take that kind of definition. Of course, we need to collaborate with Whimsy in some sense, but I don't think that that kind of a broad definition would lead us anywhere. That's my personal feeling, and I'm happy if someone can say, no, this is wrong or something like that,
You
but I
may
don't
very
think.
well be right. We can take this up with them. For instance, to me, a key attribute of a workload is that it comes to life and lifetime is bound together. So it's deployed as a unit and it is, destroyed as a unit. And again, that's just to me because that's a way to reason about something. So for instance, if you and I are having a communication between some computations happening on my machine and some computation happening on your machine, that's not one workload. It's two workloads talking to each other because I control the lifetime of mine and you control the lifetime of yours. All right, I think
Yeah,
that's kind of
but then-
intuitive and simple. But if your workload is compound and it contains multiple things, and if you choose to call that thing a workload, then it's then lifetime needs to be somehow tied at the hip.
But then if you define it per machine, so everything running on my machine is one workload. Is that your definition?
No, I said it spans devices. Because in the enterprise, when I deploy workload, it is rarely that I deploy my EC2 separately from the Lambda, that is talked over some sort of SNS queue, right? It's a workload usually deployed as a thing, as a module.
Okay, and let's take that and then talk about the identity. So what is identity in your mind? Is it the key pair that workload generated and used for the communication, whether it's SPDM or TLS or whatever it is? Is
Yes.
it the okay?
It's
So
something. It's something that. So, and I think there are three distinct use cases here. There is the identity as presented to an outside party for purposes of inbound communication. There is an identity presented to an outside party for purposes of outbound communication, and there are identities, sub-identities within the workload that the different things that comprise the workload use to speak to each other.
So what are these concretely, like the inbound, outbound, and
So
sub-identities?
inbound would be so for instance, I'm connecting to a website and I would like to submit my medical information, right? This upload form of some sort. And I would like to know that it is the precisely the workload that I chose to trust for that sort of thing. You can think like in multi-party computation, that's a great thing to do, right? So there is a workload, it's running there, it's collecting data from multiple banks and maybe healthcare institutions to do some sort of, I don't know, fraud detection. And if we're submitting our financial information into that workload, whatever comprises that workload needs to be collectively trusted. So that's for purposes of inbound. Outbound is this workload now decided to share information back with us, right? And we need to know that it is the workload that really did generate this data. We can really trust it because we chose to trust that workload, not some other. And then within that workload, you can imagine there are multiple different units of processing happening, both inside the same device, like CPU to GPU, CPU to NIC, or cross devices. And those would be, managed internally by that workload, but equally important so that we don't get imposters in there somehow.
So in my understanding, the inbound and outbound is one of them is the identity of. So I don't think we need two identities like inbound and outbound. So the workload that let's call it A and B. I think the inbound or outbound, whatever you called it, that would be, one of them will be the identity of A, and the other will be the identity of B. So A is the inbound for B, and B is the inbound for A. I think that's my kind of interpretation. Maybe I got it wrong.
They may very well be represented by different keys, right? So because if I'm submitting my request, I'm submitting to some sort of a load balancer, right? And then whatever reaches out back to me is perhaps through some other mechanism, right? So I don't want to necessarily assume that the two are the inbound and outbound are the same identity. That's why I was careful to separate them out, right? But in some cases, they very well may be.
But the workload typically has one key pair, which it uses to communicate with all
Uh,
external entities.
I don't think that's necessarily has to be the requirement, but that's one of the things we need to finesse, right? So we need to achieve agreement on like break it down into sub problems, agree on what the problem is, break it down to sub problems, make sure that individual sub problems are solved and that the totality of the solutions is coherent.
Yeah, makes sense. So we divide a problem and solve the sub problem kind of, that makes perfect sense, but I'm still struggling to see what the sub problem is for which I would need the identity for. I mean, I as a workload A, and again, A and B, thinking about that. So whether both are on the same platform or other platform, they need to somehow communicate their identities. And I currently do not see what the sub problem is for which I need a different identity for my inbound and outbound communication.
So okay,
If
so let's talk about this. So we agree that first of all, we need to agree that whatever we call a workload can span not just chips on the same device, but also span devices, right? So that let's for a second, without arguing it, just accept that.
okay, fine,
and
sure.
we can revisit it, and then you can imagine that a workload that is deployed as a unit that has that property may receive input in one of these subunits and produce output on another one of these subunits. Each of the subunits inside the workload generates and attests their own keys and obtains credentials around those keys. Again, it's possible that instead it goes to some sort of HSM and just retrieves a key for the workload. That's possible. I do not necessarily want to assume that that's the case. Now, we may decide for starting out that that's how we do it, but in general sense, if my workload comprises units A and B, and A takes the input and B generates the output, then already I have an A inbound identity and I have a B outbound identity. Now, for the A and B communicating with each other, it may be a policy inside of A that can be attested that it will only trust B to communicate with, and it must be a policy within B that is also attested that it will only trust A to communicate with, right? And all of these policies can be on your verifier or put on your verifier. So then what happens? You deploy a workload that contains A and B. A proves to the verifier that it trusts B and only B and gets an inbound identity for A. B proves to the verifier the opposite, that it trusts A and only A, and then obtains outbound identity B, and then that's how you make it work.
So my simple question in this case would be that why can't I call that what you called as sub identity or a sub workload? Why can't I call that as a simple workload rather than calling it a sub workload? I could, so again comes back to the definition of workload. I mean, I could call simply A as workload, B as workload, and then the two workloads are communicating rather than saying they are the sub identities or sub workloads part of a bigger workload. So I feel that that cycles back to the same thing.
You could do that. You could do that. Now, imagine that there is also a component C in such a workload that does not communicate inbound or outbound. It only communicates with A or B. It also obtains a sub-identity, which is C. Now, now you basically have, your workload is effectively a workload is per function, right? So if you say that A and B, in my case, have to be the same identity, then they have to get their key from somewhere else. And that's, to me, it's less than optimal because that thing can now leak. I prefer keys whose lifetime is bound to the lifetime of the enclave or the T that hosts them, because I think that gives you a more robust security for the system overall. Like today, we get our identities from key stores that we now need to manage, that we have governance requirements around. So, like, I'll just popping up a level. When I sell the concept of workload identity to the architects in my organization, when I say that we will be able to achieve all these properties, but at the same time not have to manage the individual keys, that's a huge selling point because key management is a pain in the ass. So if we can deploy firm-wide a mechanism where each workload has an identity, but that identity doesn't need to sit on some sort of key store where it needs to be lifecycle managed with revocations, with leak detection, with like all sorts of things, that saves us a lot of effort, a lot of money, a lot of headache. Right, so this is so I'm saying if we can have a specification where workload identities are ephemeral and are only live as long as the workload is up, then it's a huge improvement. It's actually better. It's easier to manage it than human identities now.
Mark, I'm listening to this very interesting conversation because the problem is very pertinent to actually making confidential computing work, as you said. I have the sense that the level at which we can solve this is at the operator level, because that's the unit that is aware of the multiple pieces that make up a deployment. And every deployment, whether it's on one machine or multiple machines, at the end of the day, it can be modeled as a distributed system. So if there is an operator which is managing the life cycle of that workload, that is the level at which we can bring the awareness of attestation to. Because it can know when a node wakes up, when a node sleeps. It can do the inter or the intra attestation between the different units that make up a workload, a distributed system effectively.
Yes.
So, right. So what I'm hearing is at the end of the day, you want something that just works for an end user. Let's say I will only release my health data to application to workload X only if I get guarantees that and it needs to be one policy. Like I need one request to the workload entirely. Like, hey, workload, can you attest yourself to me that you're not going to persist any of my health data? And the attestation should come back in one response. And in the background, the operator should do the work of attesting A to B, attesting A as an inbound, B as an outbound, whatever the model you have defined. So what I'm hearing is the following, and please tell me if I'm not getting this right.
Your observation is correct. Now let me make another observation in the same vein. We can say, we're giving you the building blocks. Operators, go figure this out. Go make it work. And really, it comes down to two things. It comes down to the danger is that you will give the same building blocks to 10 different operators, and each one of them will screw it up in their own bespoke way because they didn't understand something, or they missed something, or they neglected something, or like for whatever reason. Really, what we ought to give people in the world out there are two things. Patterns. Like if you want to solve this problem, then you need to go about it in a certain way. And this is why, like in the JRC SIG, we're actually developing patterns where we're basically listing, this is a list of things you need to consider very, very concretely out of the building blocks. So if you're developing a workload to run confidentially or payload to run confidentially, make sure that it also protects its inbound and outbound data. Right. So running inside the T is not enough if you store your data in clear text or you receive your data in clear text. Like nowhere in confidential computing, specifications does it cause you to worry about such things. So patterns is one. The second one is tooling. So you know, an enterprise has its own CI/CD pipelines, and it has various like mechanisms, and you know, the language in which a verifier policy is expressed, which regretfully right now is different in every major CSP. There isn't like a policy language around verifier, which is kind of makes deployment difficult. Now, the patterns and the tooling will develop. What I would like us to be able to do as a consortium is to provide guidance and decide among ourselves what that guidance ought to be, so that patterns can be developed and the tooling can be developed, and they all have a common foundation on which to build. Does that make sense?
I hear you. It is definitely the likeliest outcome is every operator is gonna do this its own particular way, and they're gonna cut corners in ways that are not necessarily optimal for a good what you expect of, for example, as a bank. I'm just trying to think, given the very wide ways in which operators operate, how such unifying what is the unifying added value we can bring as a consortium? That's what the question I still have in mind. You said patterns. I'm just trying to think what would that look like in practice. But I agree with the direction of travel for sure.
Right. Yeah, and again, the more you automate, the less the likelihood that somebody's going to screw something up.
Yeah.
That's why
I
we
would
have
kind of-
standard tier, like people don't go re-implementing their MTLS library every time, is because there are well-known ways of doing things. Please go ahead.
Yeah, I was kind of going to say the same thing, which is that the standardization is supposed to help us in doing things in the right way and in, let's say, not diverse the society, let's say the community in many, many different ways. So one way I see this policy is that, or one way to view these kind of policy, I had a look at the document, but I am not very convinced of how this is going to be helpful, because if you kind of give concrete, let's say, advice or suggestions or whatever you call it, so if it's not synchronized with the standards, how do you claim that's going to be helpful?
Well, this, of course, it needs to be synchronized with the standard. This is why when we develop standards, we need to understand what the standards are in the service of. Right? Because if we set the bar too low, then we're going to create a very fertile ground for bugs and for implementation difficulties and etc. Right? So, for instance, the failure to develop a policy language for verifiers is, on one hand, you can say, well, that gives people the flexibility to do things their own way. In practice, it makes your multi-cloud deployments an absolute nightmare. And if you do that, then what happens is confidential computing suffers. And like I ultimately care that we can adopt it universally and with ease. So, it's a dance. I do not expect perfection, certainly not in the near term. But what I do need is eventually us coalescing onto something where confidential computing can be deployed with, relative ease, similar to how TLS is deployed. Like, it wasn't easy to begin with, if you remember, a couple of decades ago, deploy it well. But the tooling has caught up, and the standards have caught up.
Yeah, and there I believe that attested TLS would be very helpful in kind of allowing this attestation to be standardized, so that one should not care much about what the technology is required to do, what it's supposed to do, or what are the kind of the implementation bugs and all the things that hopefully should be resolved within the TLS working group that comes out of it.
It is certainly an important building block. It's not the whole story.
Yeah, sure. So I'm not claiming it is. So yeah, sure. Yeah. It's one important building block in the whole chain.
Right. So again, popping up a level, we're 40 minutes in. I do believe that we need to align with Whimsy. I do believe that we need to be explicit about what it is that our stance is on what, workload identity is, what the bigger problem, what is the large problem we're trying to solve, how to break it down, and how to make sure that the Whimsy working group, what their output is compatible with what we are after. So we can like start thinking about how do we, if we agree on my list of things to do, and if we do, how do we get there?
I'm having in the top of my head, I don't have a model in my head of how the scope of what you're talking about here correlates to Whimsy. Like what's from a Venn diagram perspective? Because aligning with Whimsy, that's where, as far as I can tell, that's where the action is happening at the moment for figuring out attested workload identities, whatever that may mean. And so aligning or participating with the Whimsy process seems rational to help affect that and have your thoughts heard and understand what's going on. So what in addition, I'm imagining there's a superset of things you're after here that Whimsy as a standard will fall short of, and what is that?
In terms of Venn diagram, confidential computing is a subset of what Whimsy is trying to do. Whimsy is trying to be cover areas where confidential computing is not available, right? So
I get that, but the confidential compute is huge, and so you're trying to say I'm just trying to make this concrete and clear in my head. Like, so what's like an example of something that's not addressed in your sphere that you're trying to address, because Whimsy stops as a standard for how to get an identity from an identity service that's ultimately attested. So
Whimsy will tell you that there are Whimsy tokens, then there are transaction tokens, etc., and that they're not covering the entire space. So what I see is an understanding that a workload is something that is an aggregate entity, that it has a lifetime, that it may, in fact, for the same workload, there may be inbound, outbound, and internal identities, right? Like the model should map to the real world somehow, right? Then it's useful and easier to implement.
So if the Whimsy model doesn't map to the real world, how can it doesn't seem like Whimsy can become a standard, right?
If Whimsy solves part of the problem, so for instance, if Whimsy helps us solve the problem of intra workload identities, right? And then they already talk about the things called a transaction token. That's something that carries the identity throughout the workload, sort of at large, the large construct. Then maybe it's not just Whimsy. Maybe it's other standards in the identity space that help us achieve the goal.
Yeah.
But again, think multi-party compute, right? Multi-party compute is there is a workload. It's not just one EC2 instance or one Azure compute instance.
Yeah, this may be my issue, but I cannot in my head describe boundaries of what you're trying to address here. In my head, I may be incorrect in my model in my head, but I have some boundaries about what I think Whimsy is trying to do. I can't crisply in my head figure out exactly the scope of what you're trying to address here. It sounds like there's something lacking in Whimsy, but maybe that's the wrong way to look at it. And certainly, I hope it's not all of, figure out all of confidential compute problems, because that's, I think, beyond our available resources to do, right?
So my goal is not the way I see it. My goal is that I can think of an entity that I call a workload. Maybe not what Whimsy calls a workload. I don't know. But the way I define workload is a collection of units that come and go together. They have a set of ephemeral identities tied to the instance of that workload, right? And that when paired with confidential computing can have some attestation backing.
In my head, perhaps I'm wrong. I think Whimsy is going to handle that. Now, I don't have the details, not tracking the detailed conversation, but in my head, I believe
Okay.
that's
Well,
something
if so, then so much the better, right? Because then at the very least, we're going to get one workload identity definition out of it.
Mhm.
Right, and then the sub problems of there is some of the communications are going to happen between chips comprising a device, and some communications will happen between devices on which these sub workload instances run. And I just want to see a picture and an agreement that we are in fact talking about the same thing and solving the same thing.
So far from what I've seen from Whimsy, and I haven't read the docs in the last month or two, but I recall like a month or two ago, the part that caught me was where I'm looking for the huge value is, for me personally, the issues I hit or the problems I see are, I can imagine how to identify what I think of as a workload based on attestation evidence. And it's very detailed and it churns all the time. MR enclave value today, MR enclave value tomorrow. You've got a distributed set of components, each with different MR enclave values, et cetera, et cetera. And trying to kind of like always, express your trust based on that is not manageable, quite frankly. So the Whimsy thing turns it into something manageable. There's this mystical step that takes this attestation evidence into an identity server, and they give you essentially a simple a reference to an identity, and you can do your RBAC or ABAC, whatever, based on that workload identity. And the magic of how whatever that attestation evidence is, whether it's subcomponent 1 running on device 1 or subcomponent 2 running on device 2, if that should be considered part of the same workload, the magic of mapping that attestation evidence to a single workload identity happens as part of Whimsy. But I have yet to see where that process, which I think is very, very hard, it just moves this difficult process somewhere else. It moves it from the relying party into the identity provider. And how do you solve that problem? How do you make that problem something that's manageable over time?
Yeah. Yeah, I personally think, and I see a couple of raised hands, I see that the fact that we separated verifier from identity provider, grave architectural error. I already made that, I made that statement before. And I think you're hinting at the fact that we're now starting to reap the rewards of that artificial separation. So anyway, Hank, Giri, and by the way, is anyone on this call today in the Whimsy working group?
This is Hank. I'm following it. Yes, I'm subscribed to the list. I'm not attending every session or call.
Anyone been to the IITF 121 meeting?
Yeah.
Yes, I was there.
And you've seen how they're talking about like Whimsy tokens versus transaction tokens. And I have to kind of reconstruct it, pull up the presentation, but they are aware of the fact that there are different classes of identities for different sorts of things that different protocol families implement.
Yes, they are aware. That's why my first question was, is this some kind of identity composition?
Well, and I think we should be having that discussion with active Whimsy contributors in the room, so we can achieve a common understanding. By the way, I have an idea of what a good solution looks like, but I believe that the real solution that pleases everyone will emerge once we have these conversations, right? I'm just pointing out that I don't see the solution being coalesced to yet to the degree that I would be happy with.
Yeah, exactly. So I have my hand up. Sorry, this is Hank. Because next step question, so to speak. So what I hear from you is you would like to have a diagram, and a prototype diagram that shows distributions and building blocks somehow in the composition pattern. And and as an addition, I think we should start to collect the small user stories or user scenarios or whatever you want to call them. Like, you're assuming, for example, a workload is like tied to the hip, as I think was your analogy, and all the parts. But maybe it's not. Maybe there's some core parts that survive over time, a lot of life cycles of smaller parts.
Yeah,
I don't know. So there might be different lifespans of the composition. So the composition over time changes, but some parts take longer to evaporate than others. And so
Right,
that
so
might be a user story, for
we should,
example. And
yeah, we should have a common understanding of what is the lifetime of workload identity
exactly.
is,
Yeah.
right?
Yeah.
So I have my ideal scenario where, you know, workload is something that lives and dies together as a set of, you know, units, and other people may disagree, and we should like raise it and hash it out. It's just that we haven't had that discussion yet. So yes, everything you said, you know, would be a fantastic starting point, and then getting actively participating in the Whimsy working group, presenting these ideas, you know, engaging and collecting feedback and making sure that we all arrive at something that we're, you know, we're reasonably happy with. That would be great. And I think ultimately what will come out of this is the RATS RFC would probably need to get revisited to include IDP in the role of the IDP in the dance. Because what we have right now is frankly not workable.
Something tangible, yes. But I think, yeah, count me in when we are starting to drawing diagrams live at diagrams.net or whatever it's called now. And such, and build
Well,
some user
maybe
stories.
we can, maybe in 2 weeks when we meet, we can have that working group session, or maybe you know, a few of us can meet offline. I'm happy with either of those options.
Sounds good.
But yeah, again, at the very, very highest level, my goal is to make confidential computing deployable by a large enterprise like the one I'm working for. There is an interest. I can tell you that there is an interest. There isn't tooling. There isn't, you know, sufficient ease of adoption yet. Not by a long shot. Like we can, for instance, ask our any of our SaaS vendors to adopt confidential computing, and the fear is like if we share our sensitive data with a SaaS vendor, imagine Wiz, where we give them all our configuration across all our computes in the cloud. If they suffer a breach and the hacker now knows all of our weaknesses, you know, we worry about such things. But no SaaS vendor so far has been able to come back to us and say, yeah, we can deploy confidential computing. You know, just it's too hard. So that's what I'm really after.
Yeah, I'll go ahead. I think I was next on the queue. I think if you're looking for Whimsy for a solution, I think the problem is that the baseline Whimsy architecture is kind of following IETF paradigms, and that IETF, in my opinion, is self-referential, and they've adopted the OAuth framework. And you can bring in an attestation into the credential issuance, but you know, updating it and making the credential ephemeral is going to be rather difficult in that kind of framework. I think, you know, based on what I understand from what you said, Mark, I don't think that you're going to get the solution you want to, at least from an architectural level, out of the Whimsy work. You may have to actually bring in a counter architecture to what's going on there in order to accomplish what you want.
And let's not say you, let's say we, because I don't think I don't think I have sufficient firepower or intellectual power to solve all those problems. But I know that, you know, working with people who are, you know, engineers with experience in the area, together, historically, we've been able to do this.
Yeah, I think I share most of what Giri just said, because their concern is not about confidential computing. It's not even one of the things that they are thinking about. So when I talk to these people and talk about this kind of scenarios, so that's not even in their consideration in the long term. So they don't really have this in the scope. So that's what I just wanted to say.
They are and they aren't. So for instance, they were very receptive to the suggestion I made, and it made it, I believe, into one of the drafts, that the workload identity needs to avoid the use of bearer tokens. And why is that? It's because you can now have workload identities that are bound to the workload. So it's a subtle thing, but it's an important thing. So I think they would be more than willing to make sure that whatever they're doing is compatible with confidential computing. I also understand that, and I respect the fact that they need to solve it. They want to solve it for situations where confidential computing cannot offer guarantees. Fine, best effort is fine. I just, when you have confidential computing, you should be able to also use Whimsy and get better results.
Sounds like there's a pause. Seems like a few times I've heard the notion of an ephemeral workload identity. And I do not understand how that works in real life from a trust permission authorization perspective. So if workload identities are ephemeral and come and go rapidly, how does one essentially express, I allow my health information to be, released to this workload, and it's this value at this moment, it's this value then. How do I rationalize? How does that possibly work?
What's ephemeral? Maybe I misspoke, or maybe it's imprecise in my part. What's ephemeral is the key. The workload identity is a collection of claims that are vouched for by a trusted entity that is backed by a key. That key is ephemeral.
All right, so
But
then as far as I
the
can
claims
tell,
tend to be extra stable over time.
yeah, as far as I can tell, that's accounted for in the diagrams I saw in Whimsy. The part that was just left as an exercise left to the readers, the complex problem of how you describe the complicated, confidential compute environment or environments plural that comprise all the different components of this workload.
Right, and we should probably suggest something that we think can be made to work. I have some ideas, and we can discuss them and critique them. Right.
Sounds great.
So 4 minutes left. Do we want to talk about the immediate next steps?
Yeah, I captured a few of the next steps. I think the first one was to create a diagram, and the next one was user stories.
Yeah. So we can bring them to Whimsy and see how do you do these. And we can maybe start a Google's doc and just throw our ideas in there and organize them later. I don't hear anything. Did my internet just?
Yeah, no, I think you're good. But I think the question is who creates that Google Docs? So somebody
I can start it and just send a link out to the Attestation SIG mailing list. Or if you do, you guys have a folder, like a Google Docs folder, in which a document can be created. We have one in Attestation in the GRC SIG, but that's not the right place for it. And if you give me a location, I will create a doc.
Okay, Thomas, do you know a good location for tracking Google Docs on the workspace?
Under CCC attestation, you mean?
Yeah.
We can create one, and if it's not there, we can create a repo, I suppose. Do you want me to do that?
Mark, does that sound good to you?
Yeah, absolutely.
Okay, yeah.
If you give me a location, I'll start a doc, and then put some thoughts in, and then, let's just first collect all our thoughts, and then in 2 weeks go over them and try and organize.
Mark, give me a name.
Me give you a name?
Give me a name for the repo, yes. Where you want to start your stuff.
Oh, like again, for GRC SIG, we just have a Google Docs drive, like Google Drive, whatever folder. If you guys have one in Attestation SIG, let's use that.
No, we have a GitHub repo, so.
A GitHub repo, fine. Let's
All right.
Send out the link to the repo, and I will put a pull
Yeah, I
request
wanted
in.
you to mint a name for that, so that I won't make bad choices or choices we want to regret in the future.
Wait, do we want a new repo, or do we just want to use the meetings repo, which has like the PDFs for the different presentations? I know it's not a presentation, but would it make sense to place it there versus a bespoke repo for perhaps a very few number of docs over time?
That makes sense as well, yes.
Yeah, and maybe we call it workload identifier musings now and go from there.
Oh, I'm tempted to go with better than whimsy.pdf.
Okay.
All right. Okay, I will do something and
Sounds
notify.
good.
Cool.
Be
Cheers. Thank you.
politically correct, Thomas.
See you in a couple of weeks.
Bye.
Bye-bye.
Howard.
Thanks all. Take care.
Thanks.
Hey,
Bye
just
bye.
real quick, do we have a volunteer for, I think I see Thomas and Greg here.
I think the next person is Keith, and I'll be on vacation for the next couple meetings, so I'm a poor choice. I think there's one more meeting, then I suspect the one at the end of December is canceled.
Okay,
Um,
I'll reach out to Keith.
So
All
yeah,
right.
I'm gone for the next one. I'll be back in the second week of January.
Okay, in case Keith can't, I could take over.
Okay,
Bye.
thanks, Thomas.
Okay. Cheers.
Right.
Bye, Jim.
Bye.
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 Bye. Thanks all. Bye.